Chapter 7 is up next. Let's go ahead and dive in. So the first thing we studied in Chapter 7 was how to graph exponential graphs. So we are going to make an XY chart so we get a nice picture. By the way, all exponential graphs are either growing or they are decaying. Those might be upside down shapes. Now I have a positive 2 up here with my x, which means I am going to use a negative 2 as my middle number. And now it's a matter of going to my y equals and letting my calculator do the work for me. You can absolutely plug these in by hand if you would prefer. So I'm going to surround negative 2 with numbers. So I got to plug in these numbers so I have a nice shape. All right, negative 4 is 1.19 I saw. Negative 3 is 2.2 essentially, or 2.17. Negative 2 is 8, so that's a big number. Negative 1 is 43, and 0, wow, 0 is a large number. So 0 is going to give us 253. So you can choose to skip by tens if you want to skip by tens. You can choose to skip by ones, as long as you understand the fact that this graph will be moved left 2 units and up 1 unit. So it's going to approach positive 1 as it gets smaller and smaller. So I'll just skip by ones. I'll have a nice enough shape. So over 2 and up 8. Over to the left 1 and up 43. Don't think that that's going to be happening. Okay, so this is exponential growth. Just taking a look. Okay, that's right. So let's do over 3 up 2. We'll just pass 2. Not much by any means. Over 4 up over 1. And I have my exponential shape taking off.
Sorry for this disruption. I was watching my video through and I noticed I counted poorly. I had to go left 4, I went left 5. So I'm going to fix this and continue on with the rest of my explanation of this problem.
Remember, it is going to approach positive 1. You do need to make sure you indicate that it approaches positive 1, and that is because usually it approaches the x-axis, but because of the plus 1 in the back, it's going to approach positive 1. Okay, I'm going to write that on there. I'm hoping that you'll study that. So here's positive 1. This is what it approaches. Oops. And that's because of the plus 1 in the back. Okay, next we have you are going to invest $1,600, annual interest rate 4.6% compounded continuously. How much will you have after 4 years? So this word continuously, that means that you're going to use E. Continuously, use E. So I have Y equals my beginning amount times E to the percent and T. So that is Y equals my beginning amount times E to the percent times T. So the percent is 4.6, just like we talked about in Chapter 7. Please remember to divide that by 100. So you get 0.046. On the test, when I graded this, a lot of you did 1 plus 0.046, but that is not for continuously problems. Times 4, and our calculator can handle that. All right, 0.046 and 4, part of my exponents. I used the E button. If you are not sure where the E button came from, make sure I round to the nearest penny. If you are not sure where the E button came from, it is second and ln. All right, how does the graph of this compare to the parent function of this? So let's talk about all the new things. The negative sign in the front reflects it, specifically around the x-axis. The 3 in the front is a vertical stretch of 3. The plus 2 in the exponent is left 2 units, and the minus 7 in the back is down 7 units. So we have reflected, a stretch, left, and down. Number 4, due to inflation, the cost of a box of cereal increases 1% every year. So the first thing I want to do is divide that by 100. 0.01 is the decimal I am looking at. This year, the cost is $2.98. How much will it be in 17 years? So I went to Walmart grocery for you guys, and I found some Fruit Loops for $2.98. This is not the same formula, so I'm going to write it down and put an X through it. You do not use that formula because I don't see the word continuously. So instead, we use the other formula where we do 1 plus the percent in parentheses, nice and big, to the t power. So that's y equals my amount of cereal, 1 plus my percent that I divided by 100, and I am looking at 17 years. All right, Fruit Loops, 17 years. What am I going to be? Ooh, I'm going to be 52 years old. Man, I might be buying Fruit Loops for my grandkids. Wow, I'm getting old. No offense to the parents out there. So when I'm buying these Fruit Loops in 17 years, I can expect to pay $3.53. Number 5 is about the earthquakes. It's important for me to remind you that intensity is a power of 10, and energy is a power of 30. Or not a power, a base. I said power, I meant base. I apologize. All right, so let's take a look. We're going to compare. I changed this up from what it used to be, Peru and Italy. So let's find the difference between the two of them, Italy and Peru. And we're going to talk about energy. So we have 2 earthquakes, and they are asking how many more times energy was released by the earthquake in Peru than the earthquake in Italy. All right, so to do that, I need to subtract them. I think I have a little bit of room over here. Okay, so I will do 8.1, the big one, minus the small one. And I get 2.2. So sometimes kids are like, oh, it's 2.2 as much. That's not the case. This is talking about energy, so I have to do 30 to the 2.2 power. So look at that. That's a lot more energy. I'll just round. So 17,077 times as much energy. So we subtract our exponents, and then you either do intensity as 10 or energy as 30. Wow, that's a big difference. So just make sure, like on the final, if I ask about intensity, you still subtract them but use 10. If I say energy, subtract them but use 30. Number 6, there's 2 parts to number 6. I could find 2 types of problems that I can take care of here. Choose the equivalent equation in logarithmic form. So this is exponential form. Maybe you want to label that. And they want me to make it into logarithmic form. Well, logarithmic form means it has a log. I need to fill in these 2 items. The base, oh, and it's going to equal that. Remember, it always equals the exponents. Logarithms are exponents. So the base is 125. So this is always the base. Let's see, I want to write with a thicker, whoa, way too much, Langeli. This is always the base. This is the exponent. This is always the answer. Okay. I guess I'll just put like answer. I don't know. Solution. Okay. Base and exponent. So the base was 125. I think I need to shrink that down quite a bit. Of what number? 625. and that is going to equal, what is that? I need to erase it. I got too excited. 4/3. It always equals the exponent. Oops, 4/3. You can tell it's the end of the day. I don't have quite as much energy as I usually do. All right, so log base of 125 of 625 is 4/3. That's like going from water to ice, from one form into another form. Now we're going to do that again, but we're going to go in reverse, okay? So to go in reverse, this is in log form. I need it to be in exponential form. So my base is my basement of 32. My exponent is my answer, 3/5, and that equals 8. All right. I was trying to think if there's a neat little way for me to explain that. I'll try using this. Maybe you guys will like this, maybe you won't. So let's say we have a log of a number down here. Let's call it B, and then of a number A. I'll use a capital B. Then we have an ans. It equals an x and equals that. Let's say that that's our logarithm, okay? And B, A, and E, B, A, and E are numbers. Maybe I've seen this in the past, like pretend your equal sign is like a solution. See how it says the word base? Look how this applies. You would do base to the exponent, s, and then my answer. I don't know if that's helpful or not. B stands for base, E stands for exponent, S stands for solution, and A stands for answer. But then like when you put it in logarithmic form, it spells the word base. Maybe I just confused you and you need to pretend like the last 2 minutes didn't exist. All right. Let's take a look at this. It says, what is the graph of this logarithmic equation? So what I did here, guys, is we're just going to do kind of like a little free-handed drawing here. We're not going to do anything specific. Back when we studied chapter 7, I would make you do the inverse, change your XY table, adjust your XY table. How about for right now, I tell you it is enough for your final if you leave this room knowing this means left, this means down, and a log graph looks like, let's see, looks like this. And it typically approaches the y-axis, but doesn't approach the y-axis. I don't know why I drew your axes as broken, but I did. So what I'm going to do is now it's going to, instead of approaching your y-axis, it's going to approach -1 because it's moving to the left. And it's going to go like that. Oh, and it goes down 7. So it takes that turn a little lower than what we're used to seeing. There you go. That's a pretty darn good graph. If you know that that means left and down and you know the general shape, you'll be okay. Okay, let's take a look at these 3 parts here. Number 8, we have finding the value of the expression, evaluating a logarithm, and find the value of the expression. So all of these are in logs. So what I'm going to do is I'm going to remind you about change of base. Okay, so some of you are like, I can go to Google and type this in. Okay, I guess you can. But I guarantee you, if you go to Google and try to type it in versus me just using my calculator and change a base, it's going to go so much faster. All I need to do is change it to a base of 10 because my calculator is in base of 10. Even your iPhone calculator is a base of 10. So I change it to log of 92, base of 10, divided by log of 4, base of 10, and watch how fast it is. So I don't know, like on the next one, you guys can get Google pulled up and like do a mark it, set, go. But if you can, let's see, it says nearest hundredth, so it's 2 decimal spots. I mean, I can guarantee you this is just that change of base does not take very long. So I'm in my calculator, I'm going to change the base to 10. So just write log. Remember, the 10 is implied. 1 over 625 goes in the top one, and 5 goes in the bottom one. Remember, your calculator is in a base of 10, which is why we're doing the switch. And the last one, log, this is already in a base of 10. When you don't see a base written, then you can just type it in. Log 457. There you go. What does they say? Nearest hundredth. There. If you are ever interested to know if you did it right, you simply, like in the first one, you take the base of 4, you raise it to the power you got, and I'm going to get pretty darn close to 92. Now in the next one, I would do 5 raised to the negative 4th power. I get decimal, but we can change that to a fraction. There it is. And the last one would be 10 raised to the 2.66 power, pretty close to 457. I had to round, so we're going to get some icky decimals. Number 9, I could find 2 parts, and these are the properties, and we're going to make them a single log. So the property is adding means multiply. That's called the product property. That's why we put our 2 logarithms together and we did 7 times 2. That's why the final answer is log 414. The base stays. Now we'll do the properties again. When you have a number out front, that goes on to the 6, so it's like 6 squared. And then addition, so this is the power property. Oops, I spelled power wrong. And then addition means multiplication. So that's the product. I'm having trouble. That's the product property. So that was 2 things that happened. If you're wondering, like, what do you mean the 2 things that happened? Well, 6 became 6 squared, and the addition sign means you multiply by a third. So if you do 6 squared times 1/3, you end up getting this 12 that they have on this other side. So the question said, what are the properties? By the way, the other property is the quotient property. Let's see, is that there? So if I can review the quotient property real fast if anybody wants. It wasn't like I didn't give you an example. You can always look at one in your notes. It would be like log of 4 minus log of x would turn into log of 4 divided by x. That's the quotient property. Okay, so just maybe an extra little review there. And number 10, I saw 4 different types of problems that could be presented to you on the solving of Chapter 7. Chapter 7 dealt with exponents, Chapter 7 dealt with logs, Chapter 7 dealt with ln's and e's. But ln's are really logs and e's are really exponents. So they all kind of go hand in hand. So what we're going to do first here is you need to make sure that the base and the exponent is by itself, which it is. Then what you do is, since this is an exponential form and we can't solve it, we need to change it to a logarithmic form. So I'll do log with a base of 64 of an answer of 1/16 equals my exponent of 4x minus 3. And that takes into consideration what we did up above. So now what I'll do is I got to be able to put this in my calculator, so I have to change the base. So I'm going to change a base. See, I told you I do teach it to him. So that turns into log of 1/16 on the top, changing it to a base of 10, divided by log of 64, changing it to a base of 10. I mean, I have to do that to get it in my calculator. Yeah, if you have like an expensive math calculator, you might not need to change the base, but I have a free calculator, so there you go. Nothing wrong with this though. Doing well. Now, I know I get that really weird decimal, right? So no matter what I get out of this green highlight, I still need to move the 3 and the 4 over. So I'm going to hit add 3, and then I'm going to do divide by 4. I'm going to hit enter in between those, please. Otherwise, it's going to add 3 4s. Final answer. You can even probably check to see if it's a fraction. It might not be. Oh, look at that. X is 7/12. And if you're ever interested to see if you get the answer right, just put X in. Remember, we got 7/12, so watch this. 64 to the 4 times 7/12 minus 3. Check your answer. You get 0.0625. Change it to a fraction. Sure enough, it does equal 1/16. So that's the first type of problem we studied. And then we can solve logarithms. So you can see this is in a log form. I need to change it to an exponent form. So log form change to exponent. So let's check it out. Oh, but before I change it to exponent, we need to make it a single log. So these two come together, and that the addition sign means multiply. So 3x times 9 is 27x. What's my base? Oh, it's a base of 10. That's nice. Base of 10. I'm going to put that on there so I don't forget it. 3 times 9 is 27 with an x. I mean, you could change the base. You don't have to change the base, but I mean, you could. No, actually, that would be silly because our x is part of our, excuse me, our x is part of our logarithms. We better not change that base. That's right. We need to change, x is trapped by a logarithm. We need to make it an exponential form. 10 is my base, 0 is my exponent, 27x goes on the other side. So 10 to the first is just 1. Anything to the 10 to the 0 power is 1. Anything to the 0 power is 1. I'm going to drop that over here because it's getting a little scrunched there. Divide by 27. 1 divided by 27. There you go. I can leave it as 1/27th, which is fine, or I can convert it to a decimal. There you go. So for things that are stuck in exponential form, you want to change this to log form. There are things that are stuck in log form, you want to change them to exponential form. It says to the nearest hundredth. Excuse me, I'm sorry. I should have stopped there, and I should have made it 0.04. So if we round to the nearest hundredth, I should have just made it 0.04. Check your rounding. Number 10, part C. So this time x is trapped by an ln. What undoes an ln? An e. So the ln item is by itself. There's nothing outside of the ln. So we're going to change this to an e problem. So I will do, and if you're not sure why, remember ln has a base of e. So here you go. We're going to change it to an e. E to the 8th power equals 2x minus 1. I'm going to put e to the 8th on your calculator. And so I put this in my calculator. What I'm putting in a green highlight went in my calculator. I need to move that 1 over, so I'll add 1, make sure to hit enter, and then divide by 2, and make sure to hit enter. So I'm going to add 1, hit enter, divide by 2, hit enter. So I get 1490, I'm going to read the directions this time, 1,000. That's 3 decimal spots. 979. There you go. All you have to do, plug it in to double check it if you want. Nothing wrong with double checking as long as you don't run out of time. And whoops, oh, I forgot to take away 1 and get rid of that other parenthesis. I was getting 2 parentheses happy, wasn't I? There you go. Super close to 8. 10D. Ooh, x is trapped by an e. So first things first, I've got to get this by itself. So I've got to divide by 5. Got to get the e by itself. Otherwise, I cannot execute this problem. Now, x is trapped by an e. To undo an e, you need to use an ln. By the way, that's really just log with a base of e. It's just so common that we call it the natural log. It's ln. I use a capital or a cursive L so you guys don't think that I'm writing 1n. So ln of the 4 equals 2x plus 3. X is now free. I'm free. He's so happy. So type ln of 4 in your calculator, get a decimal. Subtract 3, get a decimal. Divide by 2, get your answer. So, and what do they want me to write? Oh, doesn't say, so I'll just go ahead and do negative 0.807 because that's what I feel like. And again, if you want to check it, by all means. It's not too hard to type it in. I'm just putting it in there for x. There you go, super close to 20. I think I'm good. The last one, I just wanted to make sure that you knew you could put ln's together as well as logarithms together. We did this in 7.6. It's the same as what we did in 7.4. Just remember, addition means multiply, and the things in the front, those become exponents, so, or powers. Maybe I should even, I'll use the word powers. They become powers. I got the power. All right, So this is going to be an ln. This is going to be 3 cubed. This is going to be c cubed. So that's 3 to the third times c to the third. Well, why don't we just finish? We know 3 cubed, don't we? 27. Now I've got my final answer, and that's a wrap for Chapter 7.